right? And this will be Zi minus. If you go to doing for a prismatic joint, you have linear velocity, so this will be Zi and this is it. Okay. So we need to code this for a given manifold structure. What I'm going to do is I will set up a robot configuration using a DH table. Okay. When we are doing this, you will also learn about different functionalities that come with the object robot, because when you set up a robot using a serial link command, as we always do, we set up a serial link command. The object robot has different properties. So I can do object.n, that will give me the number of degrees of freedom, or I can do robot.dh, which will give me the DH table, and so on. So we'll talk about that as we program it. I'll do this program for a specific configuration. What I expect from you is to convert this into a function so that you can eventually return the Jacobian matrix for any given robot, comma q. So you'll convert it into a function like this. What I'll do is I'll do it for a specific configuration. I want you to generalize it so that I can use any particular robot configuration. This can be any configuration and a value q so that it can give me the Jacobian. Okay. So let's try to work with one configuration, and then I'll help you set it up, and then you can submit it as a function. So you'll create a function. Right now we'll just write a simple script to do that. Let's go to MATLAB. And I'm going to create a new script here. All right. And
screen when he's typing. Yeah. The screen and the
okay, so we'll start off with defining a DH table. So I have a configuration that has one prismatic joint. So let's say L1 is equals to link okay, this is your first joint. Now, what type of a joint is this? Revolute or prismatic? Revolute, exactly, because the last parameter is 0. It's a revolute joint. And this would be a prismatic joint because you have one. And finally, we have one more link, which is L6.
Increase that one, decrease this. Okay.
Just give me 1 second.
Get to that one there.
What type of a manipulator is this? Yeah, what type is it? It's a cylindrical manipulator with a spherical wrist. Yeah, it has a spherical wrist, the last 3 degrees of freedom. If you look at all the A's, they are 0. So there is no link length, it's a wrist, it's a spherical wrist. And it's a RPP manipulator. So if you look at this here, you'll see that, where is it? Here, you'll see these 2 are D's. And finally you have the manipulator. Okay, so we want to set up this manipulator. At the same time, we want to code it in such a way that we have some degree of freedom. So for example, instead of doing it for a 6 degree of freedom manipulator, if I give you a STARA, which is 4 degree of freedom, you should be able to tell me how many degrees of freedom are there. So if you have this robot, right, and if I want to know how many degrees of, how many joints are there, what we'll do is we'll say robot.n. Okay, this will give you 6. That means it has 6 degrees of freedom. Okay, so if I want to know how many degrees of freedom are there, in this case, we can find it out like this. Okay, now one more thing that we need to know here is Jacobian needs to have a Q, right? It's a posture dependent matrix. We need to have what is Q. So if you don't have Q, you can't find out what is. So let's define here with the manipulator, we need to find the posture at which the Jacobian will be calculated. Okay, so the posture matrix is as follows: pi by 4, and we have 3, 5, and then we have angles pi by 6, pi by 3, and finally we have one more angle which is, let's keep it as 0 for now. Okay, this is my Q. So I want to find out the Jacobian at this posture of the manipulator. Alright, so to find out the posture, what I need to do is I need to know what are the Z, I's and the. So for example, if I have my T, I need to know all T0I, right? If I don't have T0I, I cannot calculate anything. So for example, I need to know.
Just for a short time. Oh, okay. Okay. This way? Yeah. Just for a short time.
Right? So this will give me here, this would give me OI. And this will be generated. How do you generate T0I? A1 up till AI. Okay? Once you multiply these, you'll be able to get that. So we need to get started with doing this so that we can find out all the Z's and OI's up till, we need to know from Z0 till Zn and O0 till On. Once you know these matrices, you will be able to construct the individual columns of the Jacobian, whether it's P or R. Okay, so let's start doing that. Let's generate the matrices. Okay. So we'll say for I is equals to 1 all the way till robot.n. Robot.n is 6 because you have 6 degrees of freedom. So all the way from here to here, I'll say n. Okay. Here, what we'll say is, first I'll say t is equals to I4. What is I4? Identity matrix. You can also set it up as the base of the robot, which is robot.base. You can use this, or you can also use this value. I can say robot.base. Okay. So for example, let me go here. Just as you have robot.n, robot.base will give you the coordinates of the base frame. This is, it's at 0, 0, 0. There is no orientation. The orientation is 0. This is an identity matrix. R3 by 3 is 0, and this is 0. So it's at the origin. So you can use either of the two. I would go with base. So, or you can, I'm just going to comment this here, or I'll say you can also write this t is equals to I4, which is a 4 by 4 identity matrix. Okay. All right. Now what we want to do is at the same time start creating a matrix which is O. Actually, let me write it as O. Okay. O will have all the O values all the way from Z0 to Zn. So I'll say O is equals to let's keep that for a second here. We'll come back. We have to set up O0 and OZ0, so we'll do that in a moment. Okay, let's go here. Now, for A matrices, we'll have to do this as follows. So, T will be equal to T times, okay, robot dot link of I of A of Q of I. What does this mean? So it will give you the first link transformation. This is the robot object. It has n number of links, 1 to 6 links, and each link has an A, right? Every link has an A. So A of Q will give you the transformation for that. So this will give you A1 of Q1, okay? This is A1 of Q1. So for example, let's go here. Let me go here so you can check your command easily. CLC. Okay. So you have robot dot links. The first link, it's A matrix, and I have to give a value because A depends on Q. So I can give this as 0. Let's say I want to give this as 0. Links for serial link, maybe it's a small l. No. Yeah. Okay, so I can change this is a prismatic joint, I can give this as pi by 3, for example, and I'll get my transformation. This is the link transformation for the first link of the manipulator.
What's A actually? I'm sorry.
A is the link transformation matrix. Okay, so when I say link 1, this is A1. Link 2 will be A2. So this is going to be links, small l, and that. Okay. So by the end of this, when you do this iteratively, because you're multiplying this to t, at the end of the for loop, you'll get t6, t06, because you're multiplying it by itself. What you're doing is, the first time you'll multiply this t times a1, second time it will be t times a2, t times a3, and so on. So you're multiplying that by itself. So here what you get is, we have to start collecting the O's and Z's when this is happening. So what we'll do here is, we'll say, we'll have to initialize this as follows: O as a null matrix. Actually, we can set it up as O0, O0, yeah, let me do it like this. O is equal to T of, because T is already generated here, O is this, O0 is this. So this will be first three rows of the fourth column. Okay? First three rows, 1, 2, 3 of the fourth column. Same way, you can say Z is equal to the first three rows of the third column. This will be Z. Okay? So this is and this is okay, third column. Okay. So now that we know, we can collect these as a column matrix. So what we'll do is, we'll set up a Z matrix like this: Z0, Z1, Z2, up till Zn. Same thing with O, O0, O1, O2, up till On. Okay? We'll keep on collecting these in a column matrix. So what I'll do here is, here, we'll say O is equal to, concatenating the old one, this is the old matrix, and then we'll have alright, and Z will be equal to so once you look at this code, once you see, you should see a complete O matrix like this, a complete Z matrix like this. So how many columns will it have, O and Z? You start from 0 to n, you'll have 7. Okay, 0 to all the way till n. So if n is 6, 1 to 6 is 6 columns, and you'll have the 0th column. Okay, so here you'll have, this is O and that is Z. You can, if you want to suppress this, you can suppress it like this, and you can only see if you want to see O and Z. Okay, now we need to start computing J. Okay, so you can decide whether it's J, if it's revolute or prismatic like this. For I is equal to 1 to robot.n and okay. Before we start, let's initialize the J matrix, Jacobian, which is like this. It's an empty matrix, null matrix. We'll initialize it like that. Yeah.
So the index exceeds matrix dimensions.
For which one? The last one? You probably gave an index larger than t. Give me 1 second, let me get this setup and give me one second. Okay, let me give you this thing and then you can fill in everything. Okay, so based on, at this point, for every link, we'll judge whether it's a Revolute link or a prismatic link, and accordingly, we'll use one of these forms, right? So what we'll do is, here I'll say if, so how do we decide whether a link is, Revolute or prismatic? Huh?
The last three.
Exactly, you'll check sigma. So in this case, what we'll do here is, function has the same name on, okay, we're probably using a variable with the same, okay, that's fine. So here, I can say robot dot links of 1 dot sigma. So this is 0, this is a Revolute link, okay? Or if I want to check if it's a link is prismatic, I'll say 1, okay? So every link I can check whether it's Revolute or prismatic by checking the sigma value for that joint. So in this case, what I'll do is I'll say if robot dot links of I dot sigma is equal to 0, right? This means Revolute joint, right? Else, obviously, it will be a prismatic joint. Okay. Now, what I want you to do here is I want you to fill out the code for J in the case of a Revolute, in the case of a prismatic, because you already have the values here. You already have O and Z here. Fill out what is, how would you add the prismatic and the Revolute part based on this. Let me help this guy out. You want?
The length was considered.
All right. Let's do the prismatic part first. I'll tell you the prismatic part, and then you can apply the same thing for the Revolute. So in this case, if you want to do the prismatic, we know that JP is Z minus 1 and 0, right? When I say 0, that means it's not, this is a 3 element, this is a column matrix with 3 elements. This is a 3 element, and this is also 3 elements. This is 3 zeros. Okay? Zi is a orientation matrix, which is this. So it has 3 elements here, which is R13, R23, and R33. So in all, the matrix should look like this. Okay? Because this is Zi, which you get from here. Okay, so now if you look at Z matrix, the Z matrix that we have, it goes like this: Z0, Z1, Z2, Z3, Z4, Z5, and Z6. It has 7 columns like this. Okay, so if a particular joint is prismatic, then what we have is Zi minus 1. So here, if you look at the index, you go from 1 to 7. Okay? Because MATLAB starts, it's not like C. The index in MATLAB starts from 1. C starts from 0. In this case, everything starts from 1. So let's say if the 5th joint, or let's say in our case, the 2nd joint is prismatic. Okay? So JP of 2, this is the 2nd joint. J2 is prismatic. So this will be equal to JP of 2. So in that case, when this is 2, Zi minus 1, which will be 2 minus 1 and 0. So this will be equal to Z1, 0. Okay? Got it? Here, the 2nd joint, so I is equals to 2. Same thing, you have the 3rd joint is also prismatic. So J3 will be equal to prismatic of the 3rd joint, that will be equal to Z3 minus 1, because Zi minus 1. Here, 0. So this will be equal to Z2, comma 0. Okay? I minus 1. But what is Z2? Z2 is the 3rd column. Z1 is the 2nd column of this matrix. Okay? So in this case, what we'll do is we'll say, because you start from 0, we'll say J. Here, in the case of a prismatic joint, J will be equal to the old J, because you're concatenating this, times Z of the column that you want. Column will be all the rows okay, let me do it like this. We need to add 2 things, right? We need to add 3 zeros here. So what I'll say is, I'll create a matrix called temp. This temporary matrix will be concatenation of Z of all the columns, comma, I, okay, and zeros of 0, comma, we want 3 zeros and 1 column. Okay, so basically, let's try it here first. Let's try it in this window. So let's say Z of 1, comma 2. This will give me this column. Now what I want to do is I want to add 3 zeros to it. So let's say I want to do this. I'll say here, I'll go here and okay, so it's concatenating it like this, but we want it as a column. So what I'll do is I'll say
semicolon.
yeah. So now let's implement this here. Okay. Now what I can do is I can add this to the temporary J. So I'll add this as J will be equal to okay. This is how you will do a prismatic joint. Now, to do a revolute joint, in the case of a revolute joint, will generate the same temporary matrix, but the temp matrix will be different. So here you will have so in this case, J revolute will be equal to Zi minus 1 cross On minus Oi minus 1 and Zi minus 1. We know how to find Zi minus 1, right? We did this right now. You want to set it up, this thing, you can write it as cross is, how do you find the cross product in MATLAB? Cross, you'll say Zi minus 1, comma, On minus Oi minus 1. Okay, you can, yeah.
For the prismatic set, it will be I minus 1.
No, that's what I explained to you. Here, Z matrix will be like this. Okay, this is Z of 1. 0 is 1. All right? In MATLAB, this is 0 of 1 because 0 starts with 1. Okay, so this will be, got it? Okay, so let's do this, write this up for the prismatic joint and then I'll do it if you can't find this out here. Find the cross product and then you have Zi minus 1.